Have you ever wondered what caused the death of nearly all life 251 million years ago? Well, there are recent reports that states new clues in the world's biggest murder mystery. So watch this video till the end to know more about this mystery. Hello and welcome back to Museum Media. Hit the subscribe button and the bell icon to never more of these interesting videos. So scientists call it the Great Dying, a period of unmatched carnage in the history of our planet. About 251 million years ago, Earth's largest mass extinction event wiped out more than 90% of all marine plants and animals and up to 70% of all land species. In a sense, the extinction marked the end of an era, closing the book on the first great pulse of life that existed on Earth and ushering in the age of reptiles. But the Great Dying is also a great mystery, maybe the greatest murder mystery of all time, because the murderer is still at large. Like police investigators, scientists are attempting to reconstruct the details of the scene of the crime, such as the timing and patterns of species turnovers, so that they can pinpoint the cause of the extinction. According to new research published in Friday's issue of the journal Science, this massive die-off likely took place within 500,000 years or less, a geological snap of the fingers for scientists. Several other tantalizing clues, including tiny metallic spheres found in fossilized rock layers dating back to extinction-age rock layers, have also been reported by the science team. These discoveries could help narrow down the field of lethal suspects in this case. Several factors are credited with causing the crisis 250 million years ago, including sea level rise, volcanic eruptions, glaciers, acid rain, global warming, and extraterrestrial impacts like the one which wiped out the dinosaurs. This extinction is also referred to as the Permian-Triassic extinction because it took place at the end of the Permian geologic period and at the beginning of the Triassic period. In a study published in Science, a group of scientists including Jin Yugan of the Nanjing Institute of Geology and Paleontology in China and Douglas Irwin of the Smithsonian National Museum of Natural History in Washington, D.C., are completing a study of the PT extinction at the site of Meishan in southern China, where a series of rock layers span the boundary between the two periods. Depending on the type of extinction, it can occur suddenly, gradually, or in a series of steps, leaving distinct patterns in the fossil record. Researchers once thought that the Meishan fossil record resembled a step pattern, recording a series of smaller extinctions over a few million years around the PT boundary. Irwin said, "A number of different people have argued for at least 3 different extinction horizons at Meishan, so we decided to see if this pattern was real or something influenced by the preservation of the fossils at the site. And to test the pattern, the researchers traced the disappearance of 333 marine fossil species in the rock layers above and below the boundary between the PT and Meishan areas. These species comprised a wide range of invertebrates with shells similar to modern clams and snails, coral reef builders, creatures that look like squids, fish, algae, and one of Earth's evolutionary pioneers, the hard-shelled invertebrates called trilobites. It's interesting to note that there are fossil-rich rock layers at Meishan sandwiched between layers of volcanic ash, which are already well dated by isotopic analysis of their chemical composition. And with the help of these ash layers, the researchers created a series of dates spanning the entire PT section, allowing them to pinpoint the last time each of the 333 species in their study appeared in the fossil record at the site. In their analysis, they predict that most of the species in their study disappeared from the fossil record 251.4 million years ago, right around the point where the PT boundary was formed. As a result, the rate of species extinction skyrocketed to 94% in these layers, up from a steady 33% in the rock layers below the PT boundary. And this dramatic increase in the extinction rate happened suddenly, occurring in less than 500,000 years. The numbers convinced Jin that they were looking at one mass extinction event rather than several smaller events clustered around the PT boundary. The extinction peak in the fossil record corresponds to a powerful shift in carbon isotope ratios, which indicates a massive death toll in marine life. The majority of species probably went extinct 251.4 million years ago, then a few lingering survivors disappeared over the next million years. Irwin said they were probably only part of a web of factors that eventually culminated in the greatest ever extinction. And that's it for today's video. We hope you liked the video. Make sure to give it a thumbs up, and for more such content, subscribe to the channel. We'll see you in the next one.